on your own time. Okay. So I've got my hexagon behind me, and we're going to start, and I am going to live stream verifying identities until I run out of examples. Okay. So to begin with, I'm actually going to start with an algebraic identity, which involves no trig ratios at all. Instead, it'll just involve a lot of techniques and things that we've seen from like a college algebra class. So to begin with, we're going to verify that x to the third minus x squared divided by x minus x minus 1 x plus 1 is precisely 1 minus x for all real values. Okay. And much of what we're going to do here in this type of identity is the same that we would be trying to do in, say, a trig identity. So here we have a couple of the procedures that we're used to on the algebra side of our checklist, and I just wanted to get familiar with these before we start going. So notice here that this is just a binomial times a binomial. So of course I can expand that out. This will become a difference of squares, which is x squared minus 1. If I distribute the negative through, then I will be able to flip both of the signs here, making this minus x squared plus 1. And notice that this is probably the one that's going to end up being in our final results. So then we have x to the third minus x squared divided by x. And notice that I could very easily write x to the third minus x squared over x as x to the third over x minus x to the second over x, because they are both in a common denominator. But that just allows me to reduce the powers of x here. So x to the third dividing out 1x gives me x squared. X to the second dividing out 1x gives me minus x. Then I'll have minus x squared plus 1. Noticing here that the x squareds cancel, which leaves me with negative x plus 1, or in other words, 1 minus x, which is precisely the result that we were trying to get. Okay. So a few things to notice here. Differences of squares are very, very, very common in trig identities. You'll see them all the time where it's like 1 minus sign or 1 plus sign, and then you have to multiply them together. And the punchline of these things, you notice this makes an x squared minus 1. Now, usually in trig, they're written backwards. So this would be like 1 minus x squared and 1 plus x squared, which will create something like 1 minus x squared. And that's in the correct form to be one of the Pythagorean identities. So of course, like when we do this with a trig ratio, if you see 1 minus sign and 1 plus sign, it's actually 1 minus sign squared, which is cosine squared. So it will always be something that reduces into another trig ratio, which is very, very nice. So that's one particular skill that we'll use going forwards here. And that happens to be example 1 in the text that I'm working out of. Okay, next we have another type of algebraic identity, 1 over x minus 1 half, which is supposed to be equal to 2 minus x over 2x. Now, verifying this type of identity is kind of trivially simple. It just involves simplifying this left-hand side here. And the good thing is this is like number 3 on our checklist for the algebra side for skills that we use for verifying trig identities. Okay, so number 3, Number 3 is going to be our common denominator procedure. And so the fast way to do this, and as I mentioned in a previous video lecture, the math teachers who may eventually stumble upon this may hate me for showing this, but it works and it's fast. So what we do is we multiply top left by bottom right, which is 2. We steal the symbol out of the middle, minus. Multiply bottom left by top right. We write it down. And then all of that goes over the bottom 2 terms multiplied together. And notice in this case, just by doing a simple common denominator, we're able to show that the left-hand side is precisely the right-hand side. And that's example 2 out of the text. Cool. Okay, so there's a couple other algebraic examples, and I think what I'll do is I'm going to skip over those because I don't see us gleaning anything else super useful from them. The next example involves differences of squares that are being factored, but since we've seen that first example where we had x minus 1 times x plus 1, we've seen how those combine to make a difference of squares. I think you'll understand that when we do a difference of squares in reverse, it's just the factoring portion of our checklist, which is number 1 on the algebra side of things. So we'll just skip right into the trig identities verifying without all the crazy algebraic nonsense. And I will be skipping any identities that we haven't talked about yet, with the exception of maybe the conjugate, because that's coming up pretty soon in class. So when we look at those, just understand I may make a few moves that seem a little bit unfamiliar, but if you catch what's happening every time I do one of these moves, it's only going to be beneficial for you in the class time, because that's the very next thing we're going into. So let's look at some items that are similar to what will be on the quiz coming up here. You may be asked to simplify something like this. So it doesn't tell you what it's equal to. Instead, it just says, let's apply trig identities and simplify this mess. Okay, so the skills that we use in verifying trig identities, we're just going to follow those pretty much exactly, trying to simplify this down. So we want to first look at it and remember that we have items 1, 2, and 3 on our checklist on the trig side. Number 1 is we look for Pythagorean identities. Number 2, we're going to look for simple product and quotient rules. And then number 3 is if we can't do anything about it, we're going to write it as sines and cosines. And I'm really going to be emphasizing here throughout this stream the idea of how we handle fractions where you see trig ratios on the bottom. And I wrote those down today as the big ideas, if you were in that class. So the big ideas are the identities that get used just an absolute ton. And what they're going to do for us is they're going to turn stuff like this into a product identity, to make simplification a little teeny weeny bit easier. Okay, so let's look at what we have. Well, first of all, I'm going to search for Pythagorean identities, and so the punchline of that is I see one thing squared plus another thing squared, I'm immediately pretty much going to say that's probably a Pythagorean identity in some way, form, or fashion. Now, this one is a super obvious one. Sine squared plus cosine squared is one of the first ones I teach in class. It is that sine squared plus cosine squared is famously 1. So I'll write that down as 1, and then we'll have over cosecant of x. Next, you'll probably notice 1 over cosecant is one of our reciprocal identities on the hexagon. But I really want to emphasize something about what those reciprocal identities actually say. What they tell you is that you can change things on the bottom of a fraction bar to something on the top of a fraction bar. Basically, I can move this here and get rid of it on the bottom, provided that I change it to the appropriate version of itself on the top. And that's really what the reciprocal identities say. So if you have a cosecant on bottom, the reciprocal identity sine is equal to 1 over cosecant says that you can move cosecant to the top, provided that you make it a sign instead. And that's really the purpose of that type of identity. It allows you to move things from the top to the bottom of a fraction bar or vice versa if it's advantageous. So here we have a nice identity that's pretty much as simple as it gets. Notice that sign is basically as far as it goes. That's like you have one trig ratio. It doesn't get much better than that. The only thing that would be better is if there was something that canceled and made it like just an integer number, like 1, 2, or 3. And that's not going to happen here. So boom, we're done. We do have a couple of viewers now. So, of course, if you run into anything that I say or do that you have a question about, make sure to pop that in the chat. And another thing is if you are looking through the test document, you'll notice that some of the choices for tonight's identities are actually pretty similar to some of the stuff that's on the test document for proofs. So will we have notes on the quiz? Yes, of course, we always have notes on the quiz. That will not ever change. You can even have the test document out and any of the proofs that we've done and be looking directly at them. The goal for you is to be looking at the examples that I have worked and say, okay, how is this similar to the one that we're working with on, say, the quiz or the test? And then you can apply some of the same concepts there. Okay, so next identity that we have out of this book is a pretty simple one. It says simplify tangent divided by secant. So simplify tangent divided by secant. And again, I want to be emphasizing what the reciprocal identities actually say. They say that you can move trig ratios from the top or the bottom to the other side of the fraction bar if you turn them into their appropriate counterpart on the other side. So secant is defined to be 1 over cosine. Similarly, cosine is defined to be 1 over secant. So what that reciprocal identity tells you is that we can rewrite secant on the bottom as cosine on the top, thus eliminating the fraction. Okay, so now what you'll notice is we have product identity. Right, so product identities. We'll have a hexagon, like a miniature version of it right here. This is tangent right here, sine right here, cosine right here, cotangent, cosecant, secant, and 1. Remember, with product identities, you just find the two things that are being times together. So cosine and tangent. Here's cosine. What's in the middle? So again, we have a trig identity that simplifies down to sine, and that's pretty much as far as it goes. Incidentally, it's worth noting that this is the kind of problem that's on the 8-question quiz. All right, so this is pretty much like what that's going to be. And it'll get a teeny weeny bit more complicated than that. Like maybe there'll be 3 of them. But if you master this trick, which is what would that be on top, then it'll turn into a product identity somewhere. So that's a super, super, super useful skill to have. And because it's just a quiz where you like type something in, you don't have to like give reasons necessarily. You won't have to like remember what specific identity it is that allows you to do that just yet. However, anytime you make a move like that, where you move a trig ratio from one side to the other of a fraction bar, it's always going to be a reciprocal identity that's enabling that. So secant goes up top and transforms into cosine. And then, of course, cosine times tangent's a product identity on the hexagon, and that's sine. I'm going to skip the one that says cosine times cotangent. I'm going to skip that because, first of all, it's nothing. And it doesn't really actually get a whole lot simpler than that. Let's look at sine squared times 1 plus cotangent squared. So we will look at sine squared theta times 1 plus cotangent squared theta. All right, so remember the checklist. The checklist says first, before we do anything else, we like to look for trig identities involving Pythagoras before we do anything else. So if we notice what 1 plus cotangent is equal to, well, we can check our identity sheet or maybe the pink sheet tomorrow and see that 1 plus cotangent is precisely cosecant squared of theta. So that leaves me with sine squared of theta times cosecant squared of theta. So sine and cosecant pair off very nicely. We can again notice, I should probably just leave this here. Again, just notice, here's tangent, here's sine, here's cosine, here's cotangent, here's cosecant, here's secant, here's 1. That sine and cosecant are directly across from each other, so their product is 1. So sine times cosecant pair off and make 1, and then sine times cosecant pair off again and then make 1. So this whole thing is just 1, and we're done. And again, as we start to get more viewers here, if you run into questions about anything that I'm doing or about one of the problems that we just worked, feel free to throw those in the chat and I will try to answer them as we get to them. Okay, so now we're on to the parts where we are actually going to start proving identities. So instead of it just being simplifying stuff, we are now going to actually prove things. I want to see how far over I can write this. I think right here. If I put the hexagon here, I should not run out of space. I don't. At least I hope I don't. It's tangent, sine, cosine, cotangent, cosecant, secant, 1. So this next identity says prove that cosine of t times tangent of t plus sine t cotangent of t. So that's tangent of t plus sine cotangent. So sine of t cotangent of t is precisely equal to sine plus cosine squared, which is this. It's off screen. No, 1 plus cotangent squared is cosecant squared, to answer that question. And that's actually a pretty decent question to ask, because the reason that we're checking the Pythagorean identities, there are some people who will start to see things like 1 plus and then just a single trig ratio. So stuff that looks like this, like 1 plus cosine of x, right? This is nothing, right? This doesn't have an identity. That doesn't simplify by itself, right? That's nothing. However, or like 1 minus cosine, that's also nothing. However, if I put a squared on there, all right, all of a sudden this has an identity. That's going to be sine squared. Okay, so if it's just a singular trig ratio, meaning it's not squared, and it's just like 1 plus or minus, or like a number plus or minus, that's nothing. But the minute that they have this squared relationship, then they are a Pythagorean identity in some way, form, or fashion. So let's work on this one. Over here, this is the simpler side, so I'm going to choose not to work with this side. We'll work with the left-hand side instead, because it's a little bit more complicated. And we have some choices here. First off, we're going to look for Pythagoras. On this side, we don't immediately see Pythagoras. So then we're going to say, all right, do we immediately notice any product identities or quotient identities that are helpful to us? Well, notice we have a sine times a cotangent. So we're going to come over to our hex. We're going to check what is sine times cotangent. Oh, hey, look, that actually simplifies. It's just cosine. Okay. So we'll have tangent t. We'll have cosine t plus, and then sine times cotangent is just cosine, so this is cosine of t. It looks like that. Okay, next, there's no identities here. We do not have any Pythagoras. We don't have anything that is super useful. So the third step is write these as sines and cosines if at all possible. And you could certainly do that, but I want to show you that that checklist is not like the definitive way to do these. It's a very helpful checklist, but we need to start recognizing that we might still have product or quotient identities when we have a distribute. So you notice we have cosine t distributed through this parenthesis. If I multiply cosine times tangent, notice that tangent and cosine just make sine. So that'll become sine of t. And then if I multiply cosine times cosine, and that'll make cosine squared of t. And notice that that is precisely what I'm trying to make over here. And so that's the whole proof. Now, in order to get full points on the test, you have to be able to tell me what identities we used and when. So in between here, we used what is called a product identity. And then that's actually the same thing we used right here. We had a cosine times tangent, which became something else. So that is a product identity as well. And you must include the name of the identity that you are using in order to get full points on the test. All right, let's look at the next one. Oh, gee, something like number 1 on the worksheet. Problem is, I don't have the worksheet in front of me. If you want to type it in as best you can, then I can work something similar to it. And we may hit something like that a little bit later from the text as well. So you type it in there just as best as you can. And then I'll see if it's similar to something that we've already done or not. Although I actually, if it's the one I'm thinking of, I think it's actually kind of like this. It may actually even be this. I'm not 100% sure. Okay. Next grouping here. Let's just do another one like that. I like that. Oh, okay. Okay, yeah. I like that. Let's secant x minus tangent times sine. Precisely equal to 1 over secant. Okay. All right, so first step, we're going to look and we're going to say, all right, do we see Pythagoras on the left? No, we don't. Do we see product identities on the left? So one thing times another that turns into something else. Tangent times sine, okay? So if we come over here, you're going to notice, let me make sure I wrote that right. Tangent times sine? Huh. Okay. Well, tangent times sine, they're right next to each other. So the question is there something in the middle? And well, unfortunately, no, there's not. Okay. So when there's nothing in the middle, that means that this thing is not a product identity, and so you have to try something else. So this is a pretty decent example because, well, now what are you going to do? Well, all we have left to do on the trig side, and there's no immediate algebra things that you see in here. In other words, we don't see a distribute and we don't see any common factors. So I'm pretty much stuck doing thing number 3 off of the cheat sheet, which is turning things into sines and cosines. So a secant from the big ideas, that's 1 over cosine of x minus tangent, which is sine of x over cosine of x. And then sine is, of course, just sine of x over 1. And what we did here, these types of identities are the quotient identities that allow us to do this, and the reciprocal identities that allow us to do this. Okay, well, fractions times fractions are pretty easy. It's just top times top, which is sine squared. Then we'll have the bottoms, which is just cosine. And over here we'll have cosine times 1, which again is just cosine. All right, that's an algebra step, so I don't need to write a reason down. Notice here that these are in the same denominator already. Okay, so when they're in the same denominator, we can just write 1 fraction over cosine with numerator minus numerator. So that's 1 minus sine squared of x. So we say, okay, what is 1 minus sine squared of x? We start over on the checklist. Do we see a Pythagorean identity? Well, of course we do. We have something and then sine squared. So 1 minus sine squared is going to be cosine squared. So I write cosine squared over cosine, which of course just reduces to one singular cosine of x, one on top, one on bottom, they cancel, leaves you with cosine of x. And then by the reciprocal identities, cosine is 1 over secant of x, which is what we were trying to show in the first place. So what I'm going to write here, this was a reciprocal identity, and what I did here, this was a Pythagorean identity. Okay. And I'll be pretty careful about not doing too many of these that are like directly from page 1. I'll try to change them a little bit from here on. But that one's simple enough that I think it's worth it. If you showed up for this or you watch this, there's a free one. Okay. Next we have, I like this one. We're gonna have 1 minus cosine times 1 plus cosine all over cosine squared. Okay. 1 minus cosine of u times 1 plus cosine of u all over cosine squared of u. Okay, so we see something squared on bottom, but in general, we don't want to apply Pythagoras to something that's just like a single object squared, because it'll create more terms as opposed to less terms. So that this would be 1 minus sine squared, but that doesn't actually help us. So instead, we're going to say, okay, well, then do I see any product identities? No, I don't. Do I see any quotient identities? No, I don't. Do I see any sines and cosine, like changing of things that would be helpful? Well, they're already sines and cosine, so that's as good as it is. Instead, what we're going to do here, I should probably say what this is equal to. This is tangent squared of u. So instead, what I'm going to say is, all right, well, let's just do algebra things with it. So can we factor something? No. Can we distribute something? Well, yeah, I have a binomial term times a binomial term. And in an early part of this live stream, I don't encourage you to go back and look at that right now, because you may miss some of the stuff here and then have trouble finding it later. But after the stream has ended, I would go back and I would look at one of those statements, which was that those 1 minus cosine, 1 plus cosine, that kind of thing. This is going to create a Pythagorean identity, because you will notice that these differences of squares, this is a difference of squares from like algebra 2, these show up quite a lot. So if I FOIL this out, this is going to give me 1 minus cosine squared of u over cosine squared. But notice now, 1 minus cosine squared is a Pythagorean identity. So this we know is precisely sine squared of u over cosine squared of u. And that is tangent squared of u, which is precisely what we were trying to show in the first place. So you say, okay, cool, that's done. Now, reasons, this was an algebra step, so it doesn't require a reason. Then moving from here to here required a Pythagorean identity, and then moving from here to here required a quotient identity. And in general, what you should do with these when you are writing your answers out, you should try not to make them as like garbaged up as I did, because they look really, really bad. Instead, try to make it where they're like kind of out the side, the line that you're writing. I don't want to hit my hexagon number 1 and then I have to rewrite it for the 13th time today. So I'm just kind of writing them in where they go, but you should in general try to put them out beside the step that required the move. Okay. All right, let's look in the book. Let's do tangent plus secant is cosine over 1 minus sine. Okay, so this one's a funny one. We're going to have tangent of x plus secant of x is, check and make sure I'm not writing the wrong thing down here, cosine over 1 minus sine. This is cosine over 1 minus sine. And again, I'm going to be working with the left-hand side here. So I'm going to look at it and say, okay, do I see Pythagorean identities? Well, tangent plus secant is similar to a Pythagorean identity, but because there's nothing squared, I'm going to skip that step and ask about the second thing. So I say, are there any products? No. Are there any quotients? No. So step number 3 is change them into sines and cosines. And the big idea identities that get used a lot are that tangent is sine of x over cosine of x, and then secant of x is 1 over cosine of x. Okay. Now, this is something that is now in a common denominator. You see they're both cosines. That means I can write a single fraction over cosine, where it's sine of x plus 1. Okay. So now, this is the first time that we hit something that we really have not seen before. So I want to talk a little bit about how I know how to do what I'm about to do. If you look at what we have now versus what we're supposed to get, you'll see that this is basically that, but it's like the wrong way over. So it's like flipped over. And then this sign is wrong. Okay, so this should be minus. Those should be reversed. And it's flipped over. Okay. So when I notice that, the definitive like fix for this is to multiply by what's called a conjugate. And conjugates are really, really easy, right? So conjugates are going to be the binomial term in this, which is sine x plus 1. So I basically just write down the same thing, sine x plus 1. So here's the sine x, here's the 1. And then I just flip what this sign is. So this is plus, I do a minus here. And if this is minus, then I do a plus here. Now, what that does, bottom times bottom, the new denominator is cosine of x times 1, I'm sorry, sine of x minus 1. And the new numerator is sine squared x minus 1. Okay. Next, you'll notice some little fiddly things that have to happen. You see, this is supposed to say 1 minus sine, which is not the same as sine minus 1. So what I need to do is factor a negative out of this, and this is a trick. Basically, anytime this is backwards, okay, we can just multiply everything by a negative, or in other words, factor a negative out. So I'm going to put a negative out in front of this thing, and that lets me switch the direction that the bottom part was in. So there you see our 1 minus sine x that we're supposed to end up with. And now I have to figure out how to get just a cosine on top. Well, notice that sine squared minus 1 is almost exactly our Pythagorean identity. The problem is it should say 1 minus sine squared of x in order for that to equal cosine squared of x. So notice that we have this nice little negative out in front. So the same trick we did down here where we factor a negative out, we can distribute that negative into another place. So like if I apply the negative to the top, that'll say negative sine squared, and that'll say plus 1. So that lets me flip around my top identity so that that is actually a Pythagorean identity. Then notice we will have cosine squared of x over cosine of x times 1 minus sine of x. And at this point, it should be pretty obvious. You see we have a cosine on bottom and 1 cosine on top, which will be precisely the cosine of x over 1 minus the sine of x, which is your required identity. Now, you got to give some reasons, all right? So we change things into sines and cosines. Basically, what that boils down to is you always write down quotient and reciprocal. This is a conjugate. It does not require a reason because it is that is a algebra move. Then we did some finagling here with the negatives. That again is an algebra move. You don't need a reason for this. You should not do what I did where I was erasing stuff though. You should actually show that you wrote the negative and then like distribute the negative through and everything. But like I tried to write those out as I was going, but I'm running out of space. And then this thing to this thing, that's a Pythagorean identity. So I'm going to write Pythagoras out beside it. And then this is just a matter of canceling some cosines and boom, there's the identity. Okay. Let me check what I have here. Yes, I agree with that statement. Cosecant would be 1 over sine and cotangent would be cosine over sine. So that is how you change cosecant and cotangent into cosines and sines. You just write anything as a cosecant into 1 over sine and anything that's a cotangent into cosine over sine. So it's quite literally the exact same move as the tangent and secant identity. It's just that this would be flipped over and then that would be a sine instead of a cosine. When changing, okay, that's a good question. No, not always. But let me tell you something where they will pretty much always, I'll say about 90% of the time, follow that rule there that you just typed in. When you do this move, when you change this into sines and cosines and change this into sines and cosines, then if you're not sure and you write quotient and reciprocal out beside it, it's probably correct because it is probably going to involve something like tangent or cotangent, which requires a quotient identity, and then it will usually involve something like secant and cosecant as well. However, I do want to draw your attention to something. Had this been tangent plus cosine, then we would only be using a quotient identity there because cosine is already in the required form. So you don't have to write reciprocal in that case. As a good rule of thumb, yeah, most of those do that. Like when you do step 3 on the checklist, yeah, that does happen most of the time. But I'm not going to say all the time. I'm going to say 90% of the time. Okay. Let's go on to another example here. Get back to some more questions in a second. All right, what do we have? We have next one. Let's do cosine squared minus 1 over cosine. So we will have cosine squared minus 1 over cosine. And this is going to precisely equal negative tangent sine. All right, cool. And that is a negative. I should probably make that darker so we can see it. Okay. Do I post the video after the live? Yes, these are automatically recorded and uploaded. That's why I wanted to do this in this format. You do have to, it'll be in the TRIG playlist, so you have to like click into it. And then I don't know where it puts that in the playlist. I think it's towards the bottom. So you may have to like click into a video lecture and then like on the side where it gives you the playlist, scroll all the way down and that should be where this is. It'll be like one of the only videos on the channel that's like over an hour long. Okay, so verifying this identity. Notice that we have cosine squared minus 1. And this is a really good follow-up to the last one because you saw that move that we did with the negative. All right. So anytime you have something that's basically a Pythagorean identity, but it's not entirely correct, meaning it's like cosine squared minus 1. So it's kind of like backwards. We can factor a negative out of that, which will let me flip around the direction of the identity on top. So that lets me move the cosine here and the 1 there. Okay. So what is 1 minus cosine squared? Well, 1 minus cosine squared is just sine squared. And the negatives along for the ride. But notice now that I have a sine over a cosine, which makes it tangent by the quotient identity. And then I have a leftover sign that doesn't get used for anything. So that's just sine x, and the negatives along for the ride. And that is precisely what I am supposed to show here. Cool. Need some reasons. Moving from this step to this step, that's a Pythagorean identity. Moving down here, that was a quotient identity. So I'll try to just kind of denote that I did that below. And then notice that this little trick with the negative, okay, this little tricky thing that I did with the negative, that's an algebra step. You don't need a reason for that. So anytime you're going to like move those, you put a negative out in front of the whole thing, and make sure you put the parenthesis in. That's really, really important. You have to say what you're factoring the negative out of, but you don't need to like write any special reasoning out beside it. So changing tangent or cotangent to sine over cosine or cosine over sine is a quotient ID, but changing 1 over cosecant or 1 over secant into cosine or sine or vice versa would be a reciprocal. Yes, that is an accurate assessment. And the easy way to remember that is if when you change an identity, like a single trig identity, it becomes two trig identities, one over the other, that's a quotient identity. And then anytime you change a trig identity and it just becomes 1 over something, that's a reciprocal identity. Give me just a second here. I've got to take a drink before I talk more. All right, moving straight ahead. Yeah, I kind of like this one. Let's do secant squared minus 1 over sine. So secant squared theta minus 1 over sine is equal to sine over 1 minus, and then I think this says sine squared. Sine squared. Okay. Cool. Okay. So, which side do we want? On this one, really kind of doesn't matter, right? They're both about the same level of difficulty. I am going to notice, though, that 1 minus sine squared is a Pythagorean identity that we should, by the end of this, kind of have locked away there. That's cosine squared. So I'm going to go ahead and work with the right-hand side of this thing just to try to make it a little bit easier to deal with. Okay. So sine over 1 minus sine squared becomes sine over cosine squared of theta. And you say, okay, that's cool. All right, well, then I can notice that 1 sine over cosine is actually a tangent. And a cosine on bottom is just a secant on top. But then you'll notice a pretty serious problem. That doesn't look anything like that. Okay. So now the problem that you have is we got to get that to say the same thing. So there is a technique here where you can, in fact, work with both sides of the equation if you need to. The only thing is, when you're doing these, you're not allowed to do things like moving something across the equal sign. So the reason why the advice is always to work with only one side is because you don't want to think that you can like plus or minus 1 to like both sides. You can't do that kind of algebra move. In other words, don't move anything across the equal sign. So I can't throw something from over here to over there or vice versa. Therefore, I can't like divide by something and have it be in anything nice at all. Okay, so what can I do with this? Well, secant squared minus 1. You'll notice that we have tangent squared plus 1 is equal to secant squared. So secant squared minus 1 must be tangent squared. So that'll allow me to change the top part of this tangent squared over sine. All right, but then notice that tangent squared, tangent squared over sine can be written using the reciprocal identities. So the move that I'm trying to get you to kind of think as a nice little hack, so to speak, is when you don't know what to do with something, like one thing over the other, what you can do is you can move something from the bottom of the fraction bar to the top of the fraction bar as long as you turn it into the appropriate thing on top. So a sine on bottom by the reciprocal identities is actually a cosecant on top. But notice that one of these tangents and one of these cosecants can multiply each other on our hexagon. Tangent times cosecant is just secant. So I'll leave us with one tangent that we didn't touch, and then a secant, which is the product of the cosecant here and one of the tangents. And that is precisely equal to what we were able to get the right-hand side to say. So we need to stick some reasons on here. This was Pythag, all right? This was also Pythag. On this side, we used a quotient identity to turn sine over cosine into tangent. And we used a reciprocal identity to turn a cosine on bottom into a secant on top. Now here we use a reciprocal identity to turn a sine on bottom into a cosecant on top. And then we used a product identity to turn a cosecant times a tangent into a secant with one leftover tangent. And there you go. There's a full proof. I like that one. How about we do some that are not in common denominators? So here we have 1 over 1 minus cosine plus 1 over 1 plus cosine. And that's going to turn into some number of secants, I believe. Okay. So we'll have 1 over 1 minus cosine of t plus 1 over 1 plus cosine of t. And that's going to turn into ultimately 2 cosecants squared. 2 cosecants squared. T. Okay. So again, when you don't know how to start something, always start with the checklist. Now the checklist here says, do you see Pythagoras on the more complicated side? And no, we don't. So do we see any products or quotients? Obviously not. Notice that we have 1 minus on bottom and we have 1 plus on bottom. So of course there's not going to be any product or quotient identities. Basically, anytime you see that, you can kind of just skip step 2 because 1 plus something on the bottom or the top is what's called a linear combination. So the plus prevents you from doing product or quotient identities because you have to handle that part first. So instead, we're stuck on algebra steps. So algebra steps, there's a pretty easy one to try whenever you have a fraction plus or minus another fraction. Just go ahead and do common denominator. So common denominator, again, the technique is top left times bottom right. You write that down, leave your parentheses, steal the symbol out of the middle, and then bottom left times top right. And then the denominator will just become whatever the bottom times the bottom is. But notice again, we have a difference of two squares. That's super, super common. You need to know how differences of squares work. So difference of squares, this is actually going to say 1 minus cosine squared of t. But that's an identity. It's a Pythagorean identity. So we're going to write down Pythag here because we're just going to go ahead and change it into sine squared of t, which is what 1 minus cosine squared actually is. Okay, well now you notice that I've got something plus something else, so I don't have to like distribute the negative, which means I can just drop parentheses. Notice I have plus cosine, I have minus cosine. So together I have 1 plus 1, which is 2 over sine squared of t. And then the move is you're allowed to change things on the bottom of the fraction bar into something on top, provided you use their reciprocal. So the reciprocal of sine is cosecant. So I have sine squared on bottom. I'm going to have 2 cosecant squared of t on top. And notice that that is the required identity. We did that by reciprocal movement. And that's that one. Let me look for a second. Again, if you have questions, I'm gonna try not to work too many that are actually off of the test document. But if you have questions, throw them in the chat so I can answer them. And take a quick breather here, because talking is hard. Give me just a minute, because I also have to get the rest of my dinner, which I haven't had a chance to eat. Hang on. All right, now we're back. So how about, don't see anything, just glaring questions. Let's do a difference to product identity. These are fun. I like these. These are really nice. Incidentally, this kind of technique is going to be extremely useful because it's a really, really common type of problem. Let me just give you an example of what I'm looking at. In this particular textbook, there are 7 examples where you have one thing minus another that turns into the product of two things. So how do you do that? Well, suppose you were asked to solve this. We'll have cotangent squared minus cosine squared. And we want to show that this is equal to cosine squared times cotangent squared. Right. So right away, this is a tricky one. The tricky thing is there's a bunch of squared terms, which makes you think Pythagoras. But then like when you look closer, the identity that involves cotangent is 1 plus cotangent squared equal to cosecant squared, and there's no cosecants here. And the identity that involves cosine is sine squared plus cosine squared equals 1. So there's no cotangents there. So Pythagoras is obviously not the correct move. Secondly, you'll notice that the product of cosine and cotangent is nothing. So we don't do anything with it. That leaves us with our last step on the trig side. Let's turn things into sines and cosines. So cotangent is cosine over sine, and then cosine is already in, using t's and x's backwards. Whoops, this is x, that's x. Cosine's already in the required form. And you say, okay, cool. Now what? Well, the purpose of doing that is that we can now do common denominator. So here we have cosine squared minus 1, or times 1. That gives us cosine squared. Steal the symbol out of the middle, bottom left, top right, that gives us sine squared times cosine squared. All over, bottom times bottom, sine squared. Okay. So now you have a bunch of sines and cosines that are all squared, but you'll notice that they're not necessarily in the correct form to use a Pythagorean identity. If this was just 1 minus sine squared, we could do something with it. Or if it was just 1 minus cosine squared, we could do something with it. But here I've got cosine squared minus sine squared times cosine squared. And you'll notice that sine and cosine don't have product identity either. So that takes us over to the algebra side of the checklist, where I'm going to look for things like distributing or factoring or conjugate pairs or common denominators. We just did a common denominator. Now there's no conjugate here because it doesn't really look like any of the problems that we've used a conjugate on. So we said, okay, let's just try factoring something out. Well, what do both terms in the numerator have in common? Well, they got a cosine squared. So if I take a cosine squared out, then I'll have cosine squared times 1 minus sine squared all over sine squared. But notice that 1 minus sine squared is just cosine squared. So that gives me cosine squared times cosine squared over sine squared. Okay, so that's cosine squared times cosine squared over sine squared. But one of these cosine squareds and this sine squared can pair off because of one of the quotient identities, and that makes cotangent. So if I take these two, that makes cotangent squared, and then look what's left over. I have a cosine squared. So this is going to make cosine squared times cotangent squared which is the required identity. And I'm done. So throw some reasons on there. We used a quotient identity here, but not a reciprocal, as was pointed out earlier. Okay, we didn't have to change this, so there wasn't a reciprocal identity. We just used a quotient. We factored something here, so we don't need a reason. And then we used a Pythagoras here, so we need to write that down. Over here, we used a quotient identity to make our cotangent squared, so I need to write that down. And then that was the end of the proof. Nice and easy. So let me just ask the chat, would it be beneficial to see another one of those? Just type yes or no in the chat. Couple of yeses. All right, so if I'm going to do 2 of these, I want you to remember what those steps were. What did we just do? So we turned the left-hand side into sines and cosines. We then did a common denominator. Then we factored something, did a Pythagorean identity, and that turned it into a quotient. And then that gave us our result. Okay. So that's turn stuff into sines and cosines, common denominator, factor something out, Pythagoras, quotient. Let's do tangent squared minus sine squared equals to tangent squared times sine squared. Okay. So now that we've seen a problem like this, we don't even really need the checklist. You just look at this and you say, hey, that looks exactly like that other problem. Let's just try the same steps we just did. Don't even bother with the checklist. Just throw it out. Let's just try the same things in the same order. Okay. So tangent becomes sine squared over cosine squared. Sine squared is already in the right form. This was the quotient identity part. Next step is an algebra step. It says do common denominator. So if this times this, steal a symbol out of the middle. If this times this, over this times this. Next, we factor something out. Notice they both have sine squared. Oh, hey, look, that's a Pythagorean identity, which is the next step from our previous problem. So this is sine squared times sine squared over cosine squared. One of these sine squareds and one of these cosine squareds pair up and make a tangent squared. And we're left with a sine squared. Factored, did a Pythag here, did a quotient here. Oh, hey, look, it's the same problem. So I'll pause here and take a couple of questions if I need to. Remember, any questions over this kind of thing, just throw it in the chat. I inhaled my drink. Oh. That's not good. How did I do the Pythag? Like right here? Right in that spot right there? I'm going to assume that's what we're talking about. Yeah. So this step here, all right. Here's the like shortened skin. This is something you can memorize right now. It'll make your life really easy later. 1 minus cosine squared is just sine squared. Okay. 1 minus sine squared is just cosine squared. Right. That way, sine squared plus cosine squared is equal to 1. Okay, so like that's what I'm doing. I'm just recognizing, hey, that's one of those things that I know, and so that's just sine squared. And you get anytime you see that 1 minus cosine squared or 1 minus sine squared, you can just replace it with the other part of that identity. So you see 1 minus cosine squared, take it out, it's sine squared. Okay. Tell you what. Let me give you one to think about to really solidify this type of proof. Let's try I guess those are a slightly different type of proof there. Well, maybe. Yeah, I want to leave that one alone. I don't like this one. This is not similar to anything you're gonna see. Um let's do this. Sine squared x cosine to the third x is equal sine squared x minus sine squared fourth x, sorry, times cosine. Let's do this. Okay, so a couple of immediate things you should notice here. Cosine to the third, all right? That's nothing. That doesn't have what I would consider a fundamental identity, meaning it's not one of the ones we're just going to like talk about all the time. So immediately, you're probably not going to do anything with this side because of the fact that's cosine to the third, and we don't have any fundamental identities for that. So when I say pick the harder side, um, that looks harder because there's more stuff. That's at least the way most people think. But what I'm going to tell you, this side is actually harder because there's no fundamental identity for that. We don't want to pick it because you don't know an identity for it. Okay, so you kind of got to have a little bit of a sense of danger here. Stuff like sine squared or sine to the fourth, like basically any even power, they usually are like masquerading Pythagorean identities. So there's like a trick with them, but it's something you can do. Odd powers of sines and cosines, that's like a calculus thing. Okay. So you don't see that all that often, and you want to try to avoid it. Like that's like a pitfall. If you can avoid it, stay away from it. So working with the right hand side, notice that you have sine squared minus sine to the fourth, which is nothing. There's no identity there. Furthermore, distributing the cosine, notice that sine times cosine is nothing. Okay, so that's not anything useful either. So can you change it into sines and cosines? Duh, already is. Don't do that. How about instead we just say, all right, let's go to the algebra steps. And the first two are factoring and distributing. Now, distributing, you should say, is a no-go because the function of distributing should be to enable one of these product identities off of the hexagon. So cosine times sine being nothing, that's not helpful. We're not going to do that. So we can try factoring. Notice that both this and that have a sine squared in common. Basically, there's two sines here and there's four sines there, so they both have two sines in common. So I can take out sine squared. That'll make that 1 minus sine squared of x, which is cosine times cosine. And 1 minus sine squared is, of course, cosine squared. Okay, that's a previous discussion. That how do you do the Pythag step? So 1 minus sine squared, we can just remove it. And that gives us cosine squared of x. And then you tell me what my next move is. Well, cosine times cosine is just cosine to the third. And look at the other side. That's what I'm supposed to have. Now, what did I do? Single Pythag right there, done. That's it. Yeah. Let me search through. At this point, the Demanda Waits textbook starts to get into some things that I would consider to be non-elementary, or rather elementary if it was a full pre-calculus course. Then I would say that it's probably fine to keep going, but I don't want to do that here. So what I'll do is look at some of the other ones here that I may like. Let me get in my drive real quick and see what I have here. Should have like maybe one or two of these that are like pretty solid in here. We'll do maybe oh, I like this one. Let's do tangent plus cotangent is equal to secant times cosecant. Let's do that. I like that one. Okay, so we'll have another sum to product identity. And those are pretty similar to the ones that we were just doing. Okay, so we'll have tangent plus cotangent is secant times cosecant. Okay, so immediate notices. Secant and cosecant right next to each other on the hexagon, they're nothing. Tangent and cotangent separated by a plus or minus, that's nothing. So there's no Pythag, there's no product quotient stuff. Let's go ahead and turn them into sines and cosine. Right? Tangent we can write as sine over cosine, and cotangent we can write as cosine over sine. Now, notice we have multiple fractions added or subtracted, pretty much immediately makes me think common denominator. Let's do top left times bottom right. That is sine squared, steal the sign in the middle. Bottom left times top right, that's cosine squared. The denominator is just the two multiplied together, cosine times sine, all right? Now, immediately you'll see a Pythagorean identity, but I want to stress something to you here. Remember that when you see stuff on like trig ratios on the bottom of a fraction bar, you can move them to the top of the fraction bar if you change them into their appropriate reciprocal. So if I put a parentheses here, now I'm totally within my right to move both of these things to the top. So cosine is a secant on top and sine is a cosecant on top because those are the reciprocals. So I can write down secant of x, cosecant of x times sine squared x plus cosine squared of x. And let me show you a little move here. That's a Pythagorean identity that is precisely equal to 1. So that whole term, if it's times something else, just poof, goes away. What are you left with? You're left with secant x times cosecant of x, which is precisely what we are supposed to show in the first place. Now, reasons these were quotient identities. And then right here, we used what's called a reciprocal identity and a Pythagorean identity to get the sine squared plus cosine squared to poof away. Cool. I like that one a lot. All right, so I'm gonna take a pause for just a second, talking for a while. I'll let you post whatever questions you might have in the chat real quick while I do that. All right, let me answer the easier question first. How do I move the sine and the cosine to the top? Anytime you have a fraction that has a trig ratio on bottom, You're entitled to move the trig ratio from the denominator to the top, provided that you change it into the reciprocal of that trig function. So if you move a cotangent from the bottom of the fraction bar to the top, it becomes tangent. If you move a tangent from the bottom of the fraction bar to the top, it becomes cotangent. With sine and cosine, their reciprocals are cosecant and secant, respectively. So if you move a sine from the bottom to the top, it becomes cosecant. If you move a cosine from the bottom to the top, it becomes secant. And vice versa. So like all of them have a reciprocal. When you move it from the bottom to the top, you just change that into the reciprocal. That's the easier question. Now the other question said, can I do this? Yes, probably. Let me rephrase that. God, I hope so. It'd be pretty disheartening if I couldn't. It says, and we're using thetas here. So this is a secant on a co. So yeah, this is funny. Okay, yeah, this is this one's a haha gotcha. Okay, so that question about how did I move the cosine and the sine to the top, I want to illustrate that again using this question directly above that. That says secant of theta divided by, and then we have cosine of theta. So this is cosine of theta minus, and then we have tangent on cotangent. Tangent theta on cotangent theta is precisely 1, and it is 1. So if you let's just do that move from the previous problem again. How do you move things from the bottom of the fraction bar to the top? Okay, so we can take cosine and throw it up here on this fraction. It's just when I move it from the bottom to the top, it becomes secant. So we'll have secant times secant, which is secant squared theta. Okay, now I can do the same thing here. If I want to take a cotangent from the bottom to the top, then it becomes a tangent by the reciprocal identity. So that's actually tangent squared. That's equal to 1. All right, what do we do here? These are reciprocal identities, all right? And then I want to just show you the one that we have. So the Pythagorean identity for tangent and secant is that tangent squared plus 1 is equal to secant squared. That's given to you. That's on the pink sheet. It's also on your hexagon sheet. And it's one of the like big idea identities. So tangent squared plus 1 is secant squared. So if I made this into, let's say I subtracted the tangent theta, let's take this, all right, and throw it over there. Well, I'd have to do that by subtracting tangent squared. Then it will say that secant squared theta minus tangent squared theta is 1. So that's a Pythagorean identity by itself. All right. So you notice what we resulted in was it's just a Pythagorean identity. There's the proof of how it works. Okay. So I can just say, all right, so how do I do this? By the Pythagorean identity, secant squared minus tangent squared is just 1. So 1 is 1. Done. What did I do? Pythagoras. And that's it. But the part I wanted to draw your attention to is that little move that we made, throwing this from the bottom to the top and throwing this from the bottom of it to the top, is what enabled this business in the first place. That's a good one. I like that. Okay, other questions? I got maybe about 5 minutes left in me. I'll give you just a second to type some stuff into the chat if you need to. Give me just 1 second. I have got to do something real quick. Well, hello, large Marge. Did you steal my seat? Yes, you did. Okay, other stuff. Other questions? Few more minutes here. You got any? Throw them in the chat. Let me answer them. Yes, I know. I took your seat and you're mad. If you find any you're unsure of, throw it in the chat. Let me answer it real quick. Got about 3 minutes left here. The Pearson homeworks are just gone. Those are just gone. I don't like the way that those homeworks are written. I don't like that it's forcing you to do one specific type of proof and nothing else. I want you to be able to kind of be creative with your answers here. And if you do it one way and it works, that's totally fine. If you do it a different way, that's also totally fine. I just have to be able to follow it. So what I will likely do is hand out some additional practice there, and it'll function a little bit more similarly to the grading system from the Algebra 2 and Geometry courses. So it'll be like, did you give me an honest attempt here? Did you work with this? If you did, then that's great. And if you didn't, well, then that's that's kind of on you. So yes, there are some, but I'm not going to have it be 3 or 4 different distinct assignments. Instead, it'll just be like 1 or 2 little things that I hand out and then get the grade that way. Uh, I have to plug those in manually on Pearson. So the most important thing is going to be the quiz over the next 2 days. And then the test document, which you currently have the first page to, and you will get the second page to here in a few days. And then you have plenty of time to work with that. And the test will be due the end of next week, which would be a Friday. You have one kind of sort of difficult problem, but we'll work through an identity that is extremely similar to it. And I say that, yeah, it is extremely similar to the one that's like the hard problem. Okay. Any last minute questions? I got about a minute left in me and I'm going to go eat. Well, okay. Do remember to suggest the recorded version of this live stream to anybody that may be asking you how to do problems over the test or over the homework. That can be found under the Trigonometry playlist on the YouTube channel there. It should be, I think, kind of towards the bottom. And tell them to skip the first 3 or 4 minutes where I'm just getting set up and like waiting for people to show up and everything. And then as soon as it starts, that's the live stream. So I will go and eat now. And good luck.